Am I audible, sir?
Yes, madam.
Sir,
Yes, ma'am. Yes, ma'am.
some noise is coming, sir. Can you go to the next screen, please? Yes.
Request to participant, please mute yourself. Yes,
Thank
ma'am.
you very
Go
much,
ahead,
sir.
ma'am.
Yeah. Fine. So this is the situation what we call here as an uncertainty. That is, we have to decide now what should be our path to go ahead to arrive certain decisions. But in our real life, we cannot take our decisions as we are moving on. So in that case, how to deal with this uncertainty? When we talk about this uncertainty, when we want to take some decisions, it is mandatory that we have to classify something like correct or not correct. So uncertainty is the one which we are unable to classify either it is correct or not correct. So this is what we call here as an uncertainty, and we are going to discuss more about this uncertainty in our databases. Next slide, please, sir. Yeah. So I just wanted you to have an information about how much of the data is collected every day through various organizations, social medias, and online resources. Nowadays, we can see that huge amount of data has been collected through this internet sources. But much of the data may be used, may not be used. But we cannot simply eradicate any of the data saying that it is of no use. There may be some of the hidden information which may be arriving to take some decisions. You can see that nowadays Google are using this recommendation system only based on our search. When you search for a book or for a product, then obviously such type of advertisements was coming into your browser as a pop-up. So this is what they call here as an intelligence. So whatever the search we did may not be useful to us, but that was taken care by the some of the people who really interested to make money on that or make it as a business. So it is very difficult to identify what are the data which is really important and what are the data which is not important, and some hidden information also to be extracted from this data. So there are various tools which we are having nowadays to assist the human being to help us to identify various data. Next slide, sir. Such type of a small example is, can you see here in this traffic signal, how many number of cars has been moving on? So we can understand that how many number of cars has been produced per year and how many number of people are using what type of cars and what was the features required by the people, so that the other people who are not in the competitor of that business can also join in that business, and then to improve their features, to make their productivity and to improve their business, right? So out of all these things, what is going to be the very important information which we have to understand? It's only the knowledge discovery. So whatever the data we collect, we can store it and we can improve the knowledge out of it by making it as in the discovery process. So this is what has been called here as KDD, that is knowledge discovery in databases and the data mining. So we are trying to mine more and more of information, but while we are mining it, we can identify that some data are really uncertain, but it has some useful information also maybe. In that case, how it is possible? So coming to this process of knowledge discovery with an uncertain data, we have some of the pattern recognition techniques. So that is what has been mentioned in this figure. The pattern recognizes the number of cars and the traffic lights available and the trucks and the name boards. You can see here that each and every information has been identified and it has been labeled it. So labeling a data is also one of the important thing when we want to do some decision making process. I hope that you are carrying out what I'm talking about. Am I clear, audience?
Yes, madam.
Thank you, sir. So the basic idea behind this knowledge discovery is the data should be without uncertainty. If you want to make a data to be uncertain, then obviously we have to go for the KDD process. So can you go for the next slide? Yeah. So this is what we call here as the KDD process. So this KDD process takes your raw data and then it will process it to produce your transformed data into a knowledge. So it contains various steps such as selecting a data and then pre-processing it, transforming it, mining and evaluating it to achieve a good knowledge about it. But you can query me, is this not available with your statistics? Yes, it is there because mathematics is base for all the real life applications. And also, we can say that statistics is one of the important subject which we are seeing in our real life in each and every cases. But when you want to deal with this uncertainty, the statistics can have to process it and then it will come up with the results. So the processing makes some of the data normalized. So in that case, some of the data may be missed or it may be highly projected. So avoid that. Can we do it using our raw data? Then we have to go for the process of KDD. Okay. So in this KDD process, we have various steps like selecting what are all the important data which are really important to make some knowledge. So that selection is what we call here as a significant attribute identification. So if you want to do such process, any of the unstructured data we have should also be made as a structured information. Yes or no? It should be made as a structured information. So structured information in the sense, it should be written in the form of some table format. So that can be done by this KDD selection process, and whatever the target we have, that we should identify, because we know that our real life is throughout with the various universes. We can see the universe of our students, we can see the universe of our faculty, universe of customers, universe of competitors. So everything is inside our real world. In that case, what is going to be our targeted audience or a targeted customers or the targeted people? Based on that, we have to go for our selection. So that is what we call here as target data. After achieving that, we have to process the data, because not always all the data may be clean. We may be having some misinformation, may be having some uncertain information, some conflicts can also be arised. So to avoid all these things, we have to process it, because we are making the data to be a consistent one. So what is meant by here consistency? Any of the data, when it is not clear, then you cannot read it into the machines, and the machines cannot identify it properly to whatever is your expectation. In that case, this pre-processing helps you to process the data, and we have various methodologies and algorithms available for processing the data and then converting it into one form to another form which can be readable by the machines. And we are trying to uh, mine the data, the hidden information from the transformed data, and we can apply various evaluation metrics and we can come up with the knowledge. So these are the various steps we have under our KDD process. So next slide, please. Yeah. So these are the various challenges we have in our knowledge discovery. So knowledge discovery is an effective approach for extracting data. Yeah, for extracting knowledge. Yes, everybody can accept that. But in our real life, do we have everything with only and certain information? No. If I talk about two objects which are on blue color, and if I ask a small child to collect a blue color, if both the objects are almost in blue color, maybe one may be a thick blue, one may be a light blue. So in that case, the child should be given a knowledge of selecting either it's a thick blue object or a light blue object. So if certain information is not given to the children, they are unable to pick the objects, right? So this is the case we have in our universe also. All these objects are having fuzzy boundaries. We already know that this fuzzy value lies between zeros and ones. That is, it we cannot say it as no, or we cannot say it as either yes. So it may be, it comes into the concept of maybe. So in that case, when we are talking about our geographic space or into our attribute space, then all these objects have their fuzzy boundaries. In such case, we have to identify our crisp boundaries, which really helps us to identify the decision making class labels. So for that purpose, knowledge discovery, to apply that and to get a knowledge discovered data, it is very, very important to have the data to be an uncertain, to be eradicated. So this uncertainty can be eradicated by one of the beautiful approach given by Pavlak. So can you give me the next slide, please, sir? So one of the important and an very beautiful approach given by Pavlak was rough set. So this rough set, so next slide please. Rough set was described by a Polish computer scientist Pavlak in 1982. Imagine, we are in now 2022, but it was discovered and described by Pavlak in 1982 itself. And it's one of the mathematical tool for understanding the vagueness and the uncertainty in the data. And why this mathematical tool is used for? To obtain our knowledge. So how do we use this rough set to obtain our knowledge? So next slide, please, sir. One of the important philosophy we have with this rough set is every object, when we take any object, it is associated with two things, two components. One is data and next one is knowledge. How do we deal the data? If the data is inconsistent, then we cannot infer with a perfect knowledge. If the data is consistent, then we can infer with the perfect knowledge. In that case, some of the objects have to be characterized. So what is object here? Whatever we have in this universe is an object. If you're talking about the university of student, each and every student is an object. So this object has been categorized with the same information, what we call here as an indiscernibility. So indiscernibility in the sense, some of the objects may have certain information which is more or less similar. In that case, the classification is totally based on the indiscernibility. We already know that the classification is based on a very, very important topic of your classical set as equivalence relation. We already know that there are three important components we have under this equivalence relation, such as reflexivity, symmetricity, and the transitivity. So here, when we are trying to classify an object, then it should satisfy this equivalence relation to identify either two of the objects are same or two of the objects are really different. So this classification can be done by the concept of indiscernibility relation. So can you go to the next slide, please, sir? If you, as I already told you, when we are taking a raw data, the data cannot be in a structured format. Then we have to make it in a structured format to discover a knowledge. So if you want to apply this knowledge discovery, it is mandatory that we have to go for a structured data, what we call here as an information system. So Pavlak has defined this information system as a quadruple, where it has a universal set and the set of attributes indicated here with the attributes A1, A2 to AN, where this universal set is a finite set of objects where it is not going to be empty at all. And we have here each and every attribute belongs to the set A with the functionality that every element in this universe have a value, that is set of values. So if you take any attribute, that attribute will have its set of values. For example, if you are talking about an attribute such as whether you are having cold, whether you are having fever, whether you are having body pain, then there may be set of attributes such as my cold is very heavy, I have a high fever, My fever is very low now, but I'm having a very high body pain. So every attribute has got its own values, right? So when we are talking about this information system, this information system is a structured one with the four quadruples, where universal set is a finite set of elements and the set of attributes, and you have the set of values. Along with that, we can categorize the set of attributes into two things, such as the condition attribute and the decision attributes. So can you go to the next slide, please? So this information system I have given you here as a sample example to talk about the various brands, the types and the price of various objects. So you can see here, this is an universe of 1 to 10 objects with brand as its one attribute, type as the second attribute, and the price as the third attribute. When you go through it, we can see that there is something similar about all the objects. On considering these three attributes, A1, A2, and A3, can you guess me what are all the objects which are already having the similar information? Can I say that this object U1 is similar to any other object? Audience, can you hear me right?
U9.
Yes.
Ninth object.
U5.
Yes.
U5. One is U5.
Exact. Yes,
U-
sir.
It is similar to U4,
U6.
U5, U8,
U6, ma'am.
U6 also,
U9.
doctor.
U6, U8, and
Nine.
U9.
Matching or not?
U3 matches with U7, ma'am.
Exactly. So U3 is matching with U7, whereas U4 is already matched with. Is it matched with any other? U4
No,
No, ma'am.
not
no,
matched.
no.
So no. So sir, can you go to the next slide, please? Yes. So here is a simple analysis on considering all the attributes. We can come up from the above information system that U1, U6, U8, and U9 comes into a single concept, whereas U3 and U7 comes into a single concept. Similarly, you have here U2, U4, U5, and U10 are having its own concepts. So how many granules we have here? 1, 2, 3, 4, 5, and 6. 6 granules are there. Is it right?
Yes, ma'am.
Is it right? Yes. So when we yeah, thank you, sir. Then, so based on this attributes, brand, type, and price, we can say that this U6, U8, U8, 9, 6, 1 cannot U1, U6, U8, and U9 are not equal to any of the other concepts. Fine. If it is with all the attributes, okay. But is there any possibility that we can take out by single attribute to see that how many number of attributes are really significant for our discovery process? Yes or no? So with the brand, with the attribute brand, what are the concepts where we can have this from the information system? Sir, can you go to the previous slide, please? Previous. Thank you, sir. So in the attribute A1 alone, how many objects we have it in common? Reebok, it has only 4 concepts, right? So similar to this, we are trying to identify what is mean by, because when we consider the 3 attributes, we have 6 concepts. If you have 15 attributes to come up to a decision, if you have in your information with 15 attributes to come up with a decision, after analysis, we found that some of the attributes, and we can come up to the same conclusion only with the 9 attributes. Then what is the need of those may live or not? We are taking it with various attributes, such as his blood should be important. Take a test which is totally irrelevant with the kidney cancer. Are you getting? So extracting some information which really helps you to identify the decisions can be done by using our rough set.
Rough.
Got it?
Yes, ma'am.
Yes, ma'am.
So this is what is very, very important in identifying the selection. Selecting which attribute is really important to go for knowledge discovery or to take a decision. Okay. So can you go to the next slide, please? Yeah. So to deal this, Roughset has introduced a very important concept called as lower and upper approximation. So we are trying to approximate the data which are already uncertain. As I already showed you the information system, which contains 10 finite non-empty sets, and we are trying to have here a set R, which is a subset of your universe, which is having an equivalence relation among themselves. Then let us give any target set, because we are not very sure which can be a target set at all. For example, as I already told you, there can be n number of students who is studying in the you are involved in the education. Imagine that if you want to identify a knowledge loss due to pandemic among the school students. So here, who is the target people? School students are the target people. When you talk about the pandemic, how much it makes a changes in the education level or the amount of making the people to understand the concept through this online courses. So the target is with the college students. So I hope that you can understand now what is mean by a target set. So targeting is what you wanted to make a decision on whom. So let us consider the target set to be the capital X, which is also a subset of your universe. As I told you, the students who are undergoing education in school are also called as students, whereas the students who are undergoing education with the universities and the colleges are also students. So it is with the universe of students on various targets. So let us consider here the target set X as the subset of U, which can be characterized by two important pair, what we call here as the lower and the upper approximation. So we have two subsets. One is what we call here as a lower approximation, where you can see it's notated by R with the bar in the bottom of it. When you have a bar, this is my notation. It can be changed according to the research papers written by the various researchers. So here I am representing the lower approximation by the lower bar as well as the upper approximation by the upper bar. Now, how the lower approximation is identified? When we have here a value y, where this value y is belonging to u by r. So what is this r? R is an equivalence relation. Can you all see me, students? Am I audible, students?
Yes, ma'am.
Yes, ma'am.
Thank you very much. So here, when we are talking about this R, as I already told you, R is an equivalence relation. Equivalence relation in the sense it should satisfy three criteria. One should be
Reflexive, symmetric,
Reflexive,
transitive.
transitive, symmetric.
exactly. Thank you very much, audience, for giving me this information. So this is to be satisfied. So when you have an element y or an object y which belongs to this u by r, where it is totally a subset of the given target itself, then we call that as a lower approximation. When any of the object which belongs to the equivalence relation, but when we do the intersection between the target set and to your object, when it is not going to be empty, then we call those things as the upper approximation. Okay, let us discuss about this with a small example. So can you go to the next slide, please? Yeah. Next slide, please. Yes. So here, let us take our target set out of the 10 objects in my universe. I'm taking here only the 4 objects as the target set. So out of these 4 elements, I'm going to identify what are all the attributes which is coming under, what are the objects which is coming under the lower approximation and the higher approximation. Okay, so previously we already have that some of the attributes, some of the objects on considering the 3 attributes. I'll just repeat again. Those objects are U1, U6, U8 and U9. So this is what is the first criteria. U1, U6, U8 and U9. If you go and see in your target set, whether you have this whole set as U1, U6, U8 and U9 in the target set, can you see anything in this target set, people? Whether the set U1, U8, U9 and one more thing, U8 and 9, 1, 6, 8, 9. Is it available in your target set?
Oh.
No,
No,
it is
ma'am.
not fully available. Yes, my query is that I want it to be fully available, but I don't have that fully available. Okay, I'll take the next concept, U3 and U7. U3 and U7, whether it is fully available in your target set?
Yes, ma'am.
Exactly. Then coming to the next concept, U2. Whether U2 is available here?
No.
No. Then coming to
Ma'am, it's
U5.
U5.
Yeah,
U5.
U5 is available. Yes. So, as I given you in the previous formula. So, go to the previous slide, please. Previous again. Coming to this lower approximation, as we have identified that U3 and U7. Audience, kindly mute yourself, please. Okay. So here you can see that this U3 and U7 as well as U5 are satisfying this lower approximation criteria so that we can make an union. Can you see the union operator before that Y belongs to U by R? So we are making a union of all these things. So when we make it out, now we can come up to the conclusion that these 3 are the lower approximation. It means that they are certainly available with respect to your target data set. That is, these are the objects which really makes your decision. Got it? Now we will discuss about the upper approximation. So next slide and to the next slide. Next slide. Yeah. So here coming to this upper approximation with respect to our target set U1, U3, U5 and U7, we can see that the first concept U1, U6, U8, U9, out of that U1 is available in your target set, right? So you can take all the objects in that particular concept. Similarly, U3, U7 is already available. We can take that. Whereas in case of U2, U2 is not available. U5 is available. Whereas U10 is also not available. And you can see in that formula, it's again an union of Y belongs to U by R intersection where Y is intersected with X. It means that we are now considering all the objects which is acting here as an upper approximation. This is the object, these are the objects which is actually may available to make your decisions or may not available to make up your decisions. So these are all the very important objects which we should understand. And you can query me, ma'am, there is U3, U7, U5 which is already existing there. Yes, I understand. But sometimes it is all in the boundary cases. We are not very sure either it is 0 or 1. In that case, we have to come up with certain formulas to identify which is really important, which attribute is really important, which attribute is not important. So from this, out of 10 objects, we can now consider how many? We already had 10 objects. But with respect to our target, we are now satisfied with only how many objects?
7.
Exactly, 7. So out of 10, you can now come up with the horizontal reduction. Can you hear about this term, horizontal reduction? That means that we already have how many objects? 10 objects. Out of those 10 objects, you can come up to a conclusion that I can do the process without 10. I can do it with only 7. So this is what I call here as the horizontal reduction. Now it is very important to identify your significant attribute. So let us go for the concept of core and reduct to identify which are all the attributes which really helps you for the decision making process. So go to the next slide, please. Yes, this is a very good diagrammatic representation of your rough set space. You can see that I have given you here in a very clean manner that you can see that this dots, the squares, the cells, we call that as the set of objects. So here U1 to U10 are my set of objects, where each and every granule, what we call it as a granule, people, the equivalence relation with respect to various attributes. Maybe with respect to all the attribute A1, A2 and A3, you have 6 concepts. We call that as attributes. If it is with respect to one attribute, you have 4 concepts. I hope that you can remember when we are discussing only with the attribute brand. We came up only with the 4 concepts. We call that as the granule of knowledge. And what is our target data set? We have created a target data set as U1, U3, U5 and U7. So let that be the target set. Can you identify something which is inside the target set, which has been bolded? What we call that as?
Target set.
No. Target is your oval.
Yes, ma'am.
That is your
Lower
target.
approximation, ma'am.
Lower
Yes,
approximating.
lower approximation. So what are all the objects we have here is the lower approximation? U3, U7, U5. They are
U5.
certainly belonging to your target. So you can see that some of the objects which is certainly falling inside my target set. Inside that oval, you can see some of the objects which is certainly falling. But you can see that the borders are touching your target set. Yes, I'm not making it very short. It is touching your borders also. Similarly, you can see that shaded rectangle on the top of your oval. We call that as an
Upper approximation. ma'am.
exactly. We call that as an upper approximation. It means that these are all the objects which have to be considered for decision making. We already have U3, U7 and U5. But in spite of this U3, U7 and U5, we have here some of the objects such as U1, U5, U8 and U9, which may help us in decision making process. That is U1, U8, U6 and U9 may take up with good decisions. So this is what we call here is mining our data. So coming with this, I can tell you that this lower approximation are called here as the positive region. So kindly come to the next slide, please. Exactly. So you can have here a clear idea about how target set is created and what is meant by lower approximation and what is meant by upper approximation separately, and what is called here is the boundary region. The boundary region is very important. And what are all the negative regions? Negative regions which will not contribute anything to our decision making process. So this is what we call here as the approximation process. So this was the work which was taken from Acharya and Abraham under the journal called Rough Computing, a review of abstraction. And I'm very honored to my guide, Dr. D.P. Acharya, who is working now as a professor in our VIT University. Now comes the next concept. Let me go to the next slide, please, sir. Thank you, sir. Now, as I told you, what is left out now? We have made the horizontal reduction already. Now what we have to do? We have to go for identifying the best attribute. Okay. So we are now going to identifying the best attribute. When you go through this, you will be slightly confused. Don't worry about any of these things. Let me partition it into small parts. So as we can see this, sir, go to the next slide, please. So the core and the reduct. The core and the reduct are identified here as any subset P of the attribute set A. Understand? P is the subset of A. What about P? P is having its attributes, where each and every attribute and its attribute values are belonging to this set P. We say this A is dispensable in P. It means that A is really important in case of your decision making process. Then we have this following condition. What is the condition to be there? When you have any universe with respect to your attribute P, then it should be equal to P by P minus A. That means if I going to take any attribute, that attribute, if it is not having any role, we call that as a dispensable attribute. There are some of the attributes which really make some decision making process. We call that as an indispensable attribute. So the intersection of all these reducts, we call that as a reduct. When we have the intersection of all these reducts, we call it as a core. Core is nothing but the significant attribute can be identified. So can you come to the next slide, please? Yes. So as I told you, there are some of the steps involved. The first step is to compute the indiscernibility relation for the combination of attribute. So let us take here the attribute A1 and A2. And I have already boxed the price because price is now not going to be considered. So kindly mask it. Otherwise, kindly make yourself hidden with this A3 and identify that what are the objects which really has an equivalence relation. You can see that U1, U1. What are all the objects which are all having similar values with respect to the attribute A1 and A2? U1, U6,
U1, U6, U8, U9.
U8, U9, U10.
Exactly. Whether that is displayed on the screen. So this is the first granule. Coming to U2, U2 doesn't have anything in common with the other objects. Coming to U3, U3 is now common with U7. Then coming to U5, you have it here as only as a single granule. Coming to U4, it is again a single granule. So you please hide yourself with the screen with the A3 and you have arrived with this granules. Now we will go to the next slide. Can you go to the next slide, please, sir? In this, previous slide, please, sir. Yeah. In this case, what I did, I started identifying the granules without the attribute A1. So without this attribute A1, when we try to find out the granules as we did previously, now we can identify that U1,
U6, U8, U8, U9.
U9 are in a single granule. U3 and U7 again in a single granule. U2, U4, U5 and U10 are in a single granule. Come to the, because we have three attribute combinations we are trying to do to find out the core value. Okay. Now we come to the next slide, sir. Next slide, please, sir. Yeah. Here on masking this attribute A2. Now we can have this granules such as U1, U6, U8 and U9 as one granule. U3 and U7 as one granule, U2, U4, U5 and U10 as the another granules. So out of these things, we have to now identify among these three attributes, which attribute is really helping us to make some decision. So go to the next slide, please, sir. Yeah, exactly. So here, I have just now consolidated all the granules you identified with A1 and A2, A2 and A3, A3 and A1. Now, what is the step ahead now? We have to now compare out of these three attributes, which is equal to that of the attribute, equal to that of the granules, which we arrived on considering our three attributes. So now you compare it and say me, what combination of attributes are equal to your three attributes? Which one is equal now? Whether A1, A2 is equal? Is A1, A2 is equal to A1, A2, A3? Universe of
No, ma'am.
So A1, A2 is not equal to the granules produced by all the three attributes. So we can say that this A3 is now indispensable. Come to the second step, search for the indispensable attributes. So it is very clear that A1, A2 is not equal to all your attribute, granule produced by all the attributes. Then we can say that this attribute A3 is indispensable. Again, now we will compare with A2 and A3. Whether A2 and A3 is equal to A1, A2, A3?
It is equal to A3, A1, ma'am.
What about A2 and A3? What about A2 and A3? Audience, can you please mute yourself? Audience, please mute yourself. Okay. So now tell me whether A2, A3 is equal to the three attributes or only A3 and A1.
All the three, ma'am.
All the three are not equal, ma'am.
No, ma'am. A1, A2, A3, A1, both in the granules are there, no, ma'am.
Yes, exactly, ma'am. That is what we wanted. So here A2, A3 is equal to A1, A2, A3. So when we compare this, we can say that this attribute A1 is indispensable. Dispensable in the sense we can remove it, because without A1 also we can come to a conclusion. Yes or no? Similarly, A2 is also dispensable, because without A2 also we are now coming to the conclusion, which is with respect to all the three attributes. So coming to this, so come to the next slide. On considering this, we can come up to the conclusion that we have A2 and A3 with respect to single attribute. We have to do other process again with single attribute, and we can come up, we have arrived to the solution that A2, A3 is not equal to A2, and A2, A3 is not equal to A3. Similarly, A3, A1 is also not equal to A3, and therefore we can come up to the conclusion that A2, A3 and A3, A1, they are the reducts. Reducts in the sense, out of these combination of attributes, we can identify that which is a intersection or the common attribute among these reducts, which is really important for the decision making process. Got it, people? So after this, we can see that among A2, A3 and A3, A1, which is a significant attribute?
A3.
Exactly. So A3 is the significant attribute. So in spite of making some decision, for example, if you want to check a person is having kidney cancer or not, by just checking the preliminary level based on the urine color alone, we can come to a conclusion that he is having a kidney cancer or not. But how much time he live or not, that we have to take it along with the various decision making attributes. Okay, so we can come out to the conclusion that we can reduce the number of attributes. We call that as the vertical reduction. Similarly, we can reduce the number of objects. We call that as a horizontal reduction. So with this significant information, we can go for certain decision making concept where the uncertainties are dealt like such in this rough set. So this is the base for our rough set. As I was discussing in the very first slide, rough set alone is not contributing to the research process of uncertainty. There is much more techniques involved with the rough set in combination with the fuzzy set, covering based rough set, much things. So I request the convener to go to the next slide, please. So we are now going to deal with the rough computing techniques. So what are the rough computing techniques we have? So go to the next slide, Celia. And before going for what are the rough computing techniques, what are the various areas that the rough computing techniques are applied? We are discussing only about the knowledge discovery from the databases, but it can be applied to machine learning. It helps in the knowledge acquisition process, decision making process and the analysis process, expert systems, inductive reasonings, pattern recognition, and with many real life applications. So we cannot say that this rough set is applied only for such area. Rough set has its application in a diverse fields. So let me go to the next slide, sir. So let me concentrate now with this equivalence relation, because that is the base for the rough set, right? So how do we make a generalization of this equivalence relation of the rough set? Some of the generalization which was already done by many of the researchers based on fuzzy equivalence relation, fuzzy proximity relation, introsystic fuzzy proximity relation, covering base rough set. Then also we have the binary relationship also. That is with respect to two universe. We are now dealing only with the single universe. We can work on with the binary relation also. Single multi-universe. So that is also possible. So now come to the next slide, please, sir. So I just wanted you to explain only with only one concept of your rough computing called here is fuzzy proximity relation. I hope that whatever the slides we have gone through so far, is it really making some understanding about how the research can be carried out with rough set?
Yes, ma'am. We get an idea, ma'am.
Okay, thank you very much, ma'am. Thank you very much, ma'am. Let me proceed further now. How do we combine our rough set with the fuzzy? Because as I told you in the very beginning, the elements or the values which ranges between 0 to 1 are the uncertain cases. In that case, how do we make a proximity, that is approximation with the fuzzy set? We call here as fuzzy proximity relationship. So how do we make an approximation among those things? So for this application, applying this fuzzy proximity relation, we cannot deal with all the three criteria of your equivalence relation. We can deal with the very important two criteria. If that is satisfied, if at least two satisfies, then we can go for the fuzzy proximity relation. So what are those criteria? When you have this mu r is nothing but my fuzzy relationship with one object to another object, where xy, xi and xj are the elements of your universe, where it is a universe of discourse. And I represent here the fuzzy proximity relation represented as mu r, where r is a subset of your u cross u. Then what are the conditions we have to satisfy? We have to identify the similarity between these two. If the similarity between the one object to the same, we have to take it as 1. Otherwise, what is the similarity between the object with respect to xi to xj should be equal to that of xj to xi. What is this xi to xj, xj to xi? Yes, we will deal with this with a small example. Okay, sir, go to yeah. So, as I already told you that R is going to be the fuzzy proximity relation on U. Let us consider some threshold value. Okay, come up with some real life example, then I will go for this. For example, whenever we are talking about something like whether today it will rain or not, that is what we call here as an uncertain situation. So today it will rain or not. When I was asking you about this, what are the things which comes to your mind? Whether is the temperature today is high or low? Whether the moisture is very high or low? That is environmental structure I am speaking. Whether you have the wind, whether it's a breeze like something, or very cloudy wind is there or no. So we are having here certain three parameters, such as either the temperature is high or low, either the wind is very high or low, that is the wind, the movement of wind is high or low, and again the moisture, whether the air moisture is high or low. Out of these three, if we have it as high or low, consider it with some value. Let us take me the temperature. If the temperature is 38 and the temperature is 32, what can you come up? Either 38 is high, 32 is low. Shall we consider like that? Shall we consider that like 38 as high temperature, 32 as low temperature? Out of these two, if I get any value as 34, Either I can say it as high or low. We are
Medium.
not sure. Medium. We are not having any attribute called here as attribute value or label called here as medium. So if that is the case, now we have to come up to some threshold value. What is the threshold value? If your temperature is 35, make it as low temperature. If your threshold, if your value is greater than 35, make it as high temperature. So if it is low or equal to 35, make it as 32 to 35. That is equal 35 or equal to 35. Make it as low temperature. If that is your condition, then you can come up to a conclusion that it is a low temperature or high temperature. That is what is represented here as the alpha. We call here as the criterion. Yeah, criterion of proximity. We call it as alpha. So this alpha value always lies between 0 to 1. Why I'm saying it is 0 to 1? Ma'am, you told us 35. Now you are saying it is 0 to 1. Yes, I told you as 35. But you imagine, I'm now ranging it with 32 to 36. So my lower value is 32. So out of 32 to 35, that is 32 divided by 35, you will get some value between 0 to 1. Yes or no? Similarly, when you approximate it now with the higher value, like 35, that is 38 divided by 35. Again, you will have some value which is lying between 0 to 1. Yes or no? Yes or no? Yes. Yeah. So with this, having this as a criteria, what are all your value ranges between 0 to 1, we have to fix our threshold. That is alpha value. Okay. And I'm going to consider here two objects. That is 32 as one object, 36 as another object. Out of these two, I want to check out whether they are similar or they are not similar. So how do I come to a conclusion? When I have to do this, I have to go for fuzzy proximity relation. So this fuzzy proximity relation have to be defined by the people according to your databases. Don't expect this type of fuzzy proximity relation to be obtained from the tools, because we are the owner of our data, and with our data we have to identify this approximation values, then we have to identify our alpha value. Got it? Now I just wanted to talk about this alpha identical and alpha similarity. So when we say that these two objects are said to be alpha identical, I'm talking about not totally identical, alpha identical, if either x1 is similar to alpha similar to xj, or xi is transitively alpha similar to xj. So let me come to a small explanation about this. And when we have such type of objects, we call that space as a fuzzy approximation space. So we are now dealing only with the objects which are almost similar. Got it, people? Which are almost similar. So now coming to the next slide. So next slide, please. Now we can say that we have arrived to a knowledge with respect to the universe objects with respect to the R, where R is the subset of U cross U, and we call this as a fuzzy approximation space. So in this fuzzy approximation space, we have to again keep a set X. What is our X, people? As we did previously, what is X? X is a notation used for?
Target set.
Exactly, target set. Here also we have to identify our target set, and we have to take the alpha value which is between 0 to 1, and the generalized generated approximation space is U comma R of alpha. That is, all your objects will be in an approximation. That is, everything is now almost similar, but they are not similar. They are almost similar, but they are not similar. Got it, people? So now again, it is necessary for us to identify the alpha lower approximation and the alpha upper approximation. Here is the definition for you for the lower approximation and the higher approximation. So kindly go to the next slide. So when you come to this next slide, we can see that this alpha upper approximation and lower approximation gives us an idea about either they are discernible or not. If you say that they are discernible, then it is to be told that the lower approximation and the upper approximation are going to be equal. It is said to be alpha rough. If and only if you are saying that it is alpha indiscernible, it means that both the upper approximation and the lower approximation of your fuzzy approximation space is equal. Then there is not necessary for you to do any similarity checking. But when we go with alpha rough is the place where you don't have the objects which are almost similar, but they are not similar at all. So this is what we call here as a boundary relation. So when you make a subtraction with the objects you have in your upper approximation with the lower approximation, we call that as the boundary elements. So here I have taken a small example for you to explain this fuzzy proximity relation. And you can see here the soil pH is notated by the attribute A1, and you can see that it has the possible values between 5.4 to 8.5, which was collected from the Vellore district in and around places of Vellore villages, and it takes the maximum value as 8.5. So now we are trying to concentrate only with the soil pH, and this is the sample data set we arrived with all our 15 attributes along with the decision attribute like predicting the level of rainfall on a particular places. Okay, so particular places, how much will be the crop yielding can happen. When we wanted to apply it, we have some of the contingency factors. So now I wanted you to explain only with respect to the attribute A1. That is your soil pH value. So you see there, we have the objects values ranging from 7.3 to 8.5. Am I right, people?
Yes, ma'am.
Yeah, exactly. So out of this, you may be having a confusion. What are all the things which comes under a certain granules? Either 7.3 is equal to 7.2 or 7.3 is equal to 7.35 or 5.4 is equal to 6.2. So many confusions we have in our real life. So how to deal this uncertainty? For this, we have gone to the next, sir, go to the next slide, please. Next slide, please, sir. Yes. So, sir, previous slide, please. So this is what has been discussed here. So the sample data set has been discussed with you. Here, on considering the attribute A1 alone, we can see that A3, sorry, 7.3 of X1 are similar with what are the other objects? Either it is similar to X12, either it is similar to X7. We are not sure about it. In that case, we have to go for certain membership identification. So go to the next slide, please. So in this case, we have to identify the degree of belongingness. So this degree of belongingness can be identified by the membership function, which we have defined here with respect to the attribute values available on my data set. So when I applied here 1 minus, because always it should lie between 0 to 1. So it is 1 minus the subtraction of the two attribute values divided by the addition of the two attribute values. You can do anything. You can do it as 1 minus the subtraction of two attribute values divided by the maximum of two attribute values. Like such also we can do. We have to do that in a trial and error basis, and we have to identify what are all the classes we are identifying. Okay, come to the next slide, sir. Next slide, sir. Yes. So this is how I have made a calculation for various places with respect to the 7.3, 7.2 against the 7.3, 7.2. Can you see that x-axis and the y-axis in my Excel sheet have the same values, where I have identified the proximities among these two with respect to the member function, which we have identified in the previous slide. So when I see how much the attribute, the object x1 with respect to x1, It is almost equal, right? So it is 1. When I go with the case of 7.3 with 7.2, they have it as 99% of similarity. Can you guess me which is the object which is having only 87% of similarity, people? Out of this attribute object x1, which is the object which is having only 87% of similarity? Object name you give me. Any object?
X18, ma'am.
Exact. X18 is having 80. I'm asking 87%.
19 and 20, ma'am.
Madam, 19 and 20 are always almost having 99% of similarity. They both are equal. It means that x1 is equal to x19 and x20. What about 87? You couldn't find 87 in the first row. That is of your Alangayam. 87, can't you see? Can you see? Okay, let me give you the answer. You can see that. Sir, is the screen visible?
Screen is not visible, ma'am.
No, ma'am.
Yes. Yeah, please. Sir, the screen is not visible, sir. Sir? Sir, kindly make the screen visible. Dr. Guneshekar, sir? Visible?
1 minute, ma'am.
Yes.
1 minute, ma'am.
Yes. Dr. Guneshekar, sir?
Wait, ma'am. I will share now.
Okay.
Ma'am, I have informed, ma'am. Wait, ma'am.
1 minute, ma'am.
Yes.
1 minute.
Yes.
Is this visible, ma'am?
Ma'am, go to the slide number 36, please. Dr. Guneshekar, sir?
Wait, ma'am. I will share now.
Okay.
Ma'am, I have informed, ma'am. Wait, ma'am.
1 minute, ma'am.
Yes, 1 minute.
Is this visible, ma'am?
Yes, ma'am. Visible, ma'am.
Visible, ma'am. Can you go to the slide number 36? Go to the slide number.
Wait, ma'am. I will share now.
Ma'am, I have informed, ma'am. Wait, ma'am.
1 minute, ma'am.
Yes, 1 minute.
Is this visible, ma'am?
Yes, ma'am. Visible, ma'am. Visible, ma'am, but maximize the screen, ma'am.
One minute.
Ma'am, give enable editing and then try, ma'am.
Is this okay, ma'am?
Yes, ma'am.
So this is the point where we have stopped. So we were discussing about the various places of Alangayam. Out of this, what are the objects which are having almost similarity, isn't it? Okay. So let me come back to the thing. So we can see that this object 16, x16, when you see the alangayam, just have a look on that row. Sir, ma'am, come to the next slide, please. Next, please. 36 slide, ma'am. Slide number 36. Yes, ma'am. Thank you. So here you can see that when we come up to this object x1 and its corresponding object x13 is having the similarity index of only 87%. Like such, we have to identify, based on the membership function we defined, how each and every object are similar among the others. Now, after arriving this, we have to identify what should be the threshold value to identify the classes. So, coming to, sir, ma'am, can you come to the next slide, please? Okay, ma'am. Thank you. So here we can come to a conclusion that if your alpha value is greater than 0.95, if you make this alpha value to be greater than 0.95, then these are all the classes I identified. You can see that this mu r of A1 with respect to x1 and x1, it is 1. That is, they are 100% similar. Whereas with x1, x2, it is 99% similar. x2 and x3, it is 1%. Almost all equal. Okay, 100%. Now coming to this u to x20 and x1, it is 99%. So like this, we are trying to identify the alpha identical objects. Similar to this, as I did previously, we have to identify that what are all the objects which are all identical. So these identical objects has been identified based on your equivalence relation has been generated here as mu of r with respect to the alpha, that is your alpha value to be 0.95. Then it goes to with respect to the attribute A1. You can see that it has been divided into 4 classes. I have a simple question. Ma'am, go to the previous slide, please. I have a small question here. If, ma'am, previous slide, yeah. So here, if I keep this alpha value to be 0.95, then I can see that x that is greater than whatever you have under the criteria of 0.95 above. Then x1, x2, x3, then x7. You have to leave out x6, isn't it? Now come to x8, it is also less than 0.95. Like moving some of the objects, and we are identifying its similarity in the consecutive rows. If I make the alpha value to be very small, like 50%, then how many number of classes I may receive here? All objects will come under a single class, isn't it?
Ma'am, if it is below 50 means all it comes under.
Below 50 in the sense all will come into a single class. But our aim is to make a classification. So you have to decide your alpha value to some threshold value so that it gives you the maximum number of classifications. You can question me, ma'am, why can't you make it as 90 instead of 0.95, make it as 96? Yes, possible. But if I make 96 and if I make 95 also, with so many trial and errors, I have identified that 0.95 and 0.96, 0.97, 0.98 and 1 gives me the same number of classes. When I go below 0.94, I come up with the number of classes reduced. But when we want to take a decision, the classes has to be identified. So go to the next slide, ma'am, please. Next slide, ma'am. Yeah, next slide, please. Next. Yeah, next to it. next to it. Yes. So, and categorizing these attributes, we have here 4 classes. Similarly, when I does this operation for all my attributes, that is for my soil pH, and also I have something like moisture, organic matter, zinc, magnesium, all these 15 attributes. Now I have arrived with 6 separate class labels, which I have categorized here as very high, high, moderate, low, very low, and poor. And that is how the previous data set what we created is now reduced into a quantitative information system. And coming to this rough set, how this rough set works better. Either it works better for your qualitative data or a quantitative data. Rough set deals better with the qualitative data too. Whereas when you go with the statistical methods, it works better with the qualitative data. But when you work with your qualitative information system, the rough set gives you better results. So that is how I converted that is the transformation has been happened from the numerical data set into this qualitative information system. So these are all the things we can do under the fuzzy proximity relation to obtain a good results. So from this qualitative information system, we can go for our decision making process. Hope so. So with all these things, we are going for the next slide as hybridizing our rough computing. Go to the next slide, please, ma'am. Yes. What are the existing techniques, hybridized techniques we have with the rough computing? There is many hybridization happened with the rough computing along with the rough set and fuzzy proximity relation, with the neural network, with the genetic algorithm, with the support vector machine, formal concept analysis, particle swarm optimization technique, bio-inspired computing. All these are the machine learning and deep learning techniques we have. So nowadays I can see that we are already working on with the various combinations in a transdisciplinary manner. In that case, this type of hybridization of your rough computing with the other techniques may give you a very better research directions. Now coming to this, ma'am, go to the next slide. Rough computing has been applied into various areas. What are the areas it has been applied? First thing is with the knowledge representation. That is, it was been identified by Acharya sir as well as Dubais and Parade in the year 1988 itself and in 2008. And also you can see that there was also a combination, that is hybridization of rough computing with the prediction process in the fault diagnosis. One of the work which was done from my side and my guide as predictive data analysis process. So which was presented in the hybridization in the prediction process. Ma'am, go to the next slide. And the rough computing can also be hybridized in an agriculture science. So here we have again produced, that is what has been presented in the slide as crop prediction system using rough computing and neural network. Also, there was again one more thing with the genetic algorithm. Similarly, ma'am, go to the next slide. We can have an hybridization with various things like healthcare systems as well as with the industrial applications. Even now in the prediction with the business intelligence. So rough computing is suited for any field of study, whatever you want to carry out. So, ma'am, go to the next slide, please. So with this, I want to conclude that we have a wide range of research directions with the area of applications with our rough set. And when we go through the real number of work carried out so far was very, very limited. And the hybridization also has improved our research direction. But still, there is some of the applications which are yet to be done. For example, in your ambient intelligence, cultural heritage, text processing with rough computing techniques. And also, it is rarely integrated with the structural equation modelings, partial least square while analyzing the primary data. So there is a lot of scope with our rough computing techniques. So I request all our researchers to do some data analysis with this rough computing techniques to get more and more directions towards your research work and can contribute more towards your research area. So with this, I conclude my talk, and it's now open to you all to have your queries.
Ma'am, how you generate the table, ma'am? 0.99, 0.88.
Yes, yes. I will tell you. Can you go to that slide, ma'am? The slide number is 37. Madam, kindly go to the slide number 37 or 35 also fine. 35 is better, ma'am. Yes, ma'am. Thank you. Now, this is the formula which I have applied, and this is the formula which I have identified my data set. Okay. You apply here xi as 0.73, which has been showed in your table. I have already shared you one table. So you make that xi as 0.73 and the xj as 0.72 and apply this formula. 1 minus 0.73 minus 0.72 divided by the 0.73 plus 0.72. You will get your value as 0.99. 0.99.
Okay, ma'am. Okay, ma'am. Thank you.
Like this, we have to do it for all the objects across the objects, all the objects to itself and to the approximation. Now you can see, ma'am, go to the next slide, please. You can see on my screen that this diagonals, all the diagonals are having 1. Why it is having 1? Because x1 is similar to x1. x2 is similar to x2. Yes or no, people? So x10 is similar to x10. Yes or no?
Yes, ma'am. Yes, ma'am. Yes,
So you
ma'am.
can see that this is clearly dividing your uncertain data into 2 categories, and out of that we are identifying our classes. So this is how we have to identify. So 2 important challenge we have in doing this fuzzy proximity is the membership function identification, and the next one is the alpha value, that is your threshold. Either you have to give it as 0.95 or 0.50. If you make 0.50, it will come into a single class. Then where is the classification? We cannot give the class labels at all. When you can't give the class labels, we cannot make it as a qualitative information system which cannot be applied into the rough set. I hope that I have answered your query, ma'am.
Yes, ma'am. Thank you, ma'am. But the
Thank you.
formula is different for each and every project, no, ma'am?
Yes, ma'am. According to your data, you have to identify your membership function. That is the true challenge we have for this fuzzy proximity relation. But once we get practiced with our data and the pattern we recognize how the data are working, it is easy for us to do. Actually, for rough set alone, not for fuzzy proximity relation, a tool was missing for fuzzy proximity relation. But if you want to work with your rough set and to identify the rules, we have a software called as ROSE, R-O-S-E, that is Rough Set Explorer, Data Explorer, ROSE is a software we have. Since I am unable to share my screen, I thought of showing you the calculation part also. Since I am unable to share my screen, I'm unfortunate to show you those things. Kindly
Ma'am, is
pardon.
it paid or is it free software, ma'am?
Software is open source, ma'am. You can download from your internet source. But it works only for your rough set, not for the rough computing techniques such as fuzzy proximity relation, fuzzy relation, rough set, rough fuzzy set, intercentric fuzzy rough approximations. There are various generalizations has been happening in this rough computing technique.
Thank you, ma'am.
Any other queries you have?
Ma'am, in
Good afternoon, ma'am.
37.
Can you explain the difference between a soft set and rough set, ma'am? Because my
Exactly,
research area is fuzzy soft matrix in medical diagnosis. So can you explain what is the difference between rough set and soft set?
Yes, ma'am. Actually, when we are dealing with the rough set, we no need to think about the parameters at all. Whatever is existing, we can work on it. But when you come to your soft set, we have to categorize according to our attributes. I hope that you might have seen some of the examples for your soft set, such as the number of houses we have, that is single bedded houses, double bedded houses, and deluxe houses, duplex houses. So all these are some of the categories, and it always falls as zeros and ones. It
Yes.
means that some of the features of those houses, that is, we are dividing it into another one more category. Here we are accepting, that is in rough set, we are accepting all our attribute as such it is. and we are doing some uncertain checking process. That is in case of rough set, each and every attribute for that object have to be considered. As I told you, the objects such as single bedded houses. So here, what is the price of it? What is the location of it? And what is the dimension of it? Similarly, when you go for the second object, such as a duplex house, then what is the dimension? So every attribute have to be identified, and you cannot take it as the fuzzy values. But when you work with the fuzzy soft set, then you can simply apply that as I did before with the fuzzy with your soft computing technique. Soft set techniques.
Soft set matrix.
Yeah,
Okay,
soft set
thank you,
matrix can be done. Yes. Any other queries we have, people?
Oh. Okay, ma'am, one question, because in screen we are seeing that proximity relation
sir.
attribute table, because it's like a table. And what is the difference between this table and random numbers table? Can you correlate anything?
Random numbers is
Numbers
nowhere.
table.
No, sir. I don't think random number table cannot be related with this fuzzy proximity relation, because here we are dealing with the actual numbers of our data. We are not dealing with any random numbers, sir. We are dealing with the data, but among those data, that is objects, how much they are similar or not similar. So we are nowhere related with the randomization here.
Okay,
Even not
thank you.
normalization also.
Okay, thank you, ma'am. Thank you.
Yes, sir. Any other queries?
Good afternoon.
Yes, ma'am.
In 37 slide, uh, before you have asked that which object which is 87%, how to find that, ma'am? That is which is 99%, which object it is?
Yeah. Sorry. This one, this slide, 37 slide is wrong one. Go to the 36 slide. 36 slide gives you correct idea. Maybe while printing it, that is while copying it, I made a mistake. The slide number 36, which was computed with the Excel sheet. Ma'am, go to 36, ma'am. Yes. Here, can you see, ma'am, this 87% for X13 with respect to Alangayam, X13. Just go through this X1 row, and you can see this X13 is having. Can you see, ma'am?
I can able to see, ma'am.
This that is what is the relationship here. X1 to X13, that is 7.3. How much it is similar with the 8.5? We have to now talk about the data. 7.3, how much is related with 8.5? They are related only 87%. So they will not come under a single class.
Okay.
Why I'm very certain about this? Because our alpha value is greater than 0.95. Since there is no relationship between this X1 and X13, which is not falling greater than 0.95, I can certainly say that X1 will be in one class, X13 is in another class.
Okay, ma'am. Okay.
Thank you.
Thank you.
Any other queries, ma'am? Yes.
Thank you, ma'am.
Is there any? We will conclude the session.
Can you come again, please?
Okay, ma'am. We will conclude the session.
Oh, okay.
Thank you, ma'am. Thank you for your awesome presentation. It will be very interesting for us to know some lifetime applications of fuzzy, which will be applied further. I also extend our thanks to all the participants for your participation. Kindly fill the feedback form, which is in the chat box. Now the session is over. Next session will start at 2:45 a.m. Thank you.
And I'm also very much thankful for each and everybody who have given you so much of patient time and listening for this topic of dealing with uncertainty. I hope that I have given you small information on your research topic, and I was very much thankful Dr. Guneshekar sir and his team for organizing such a wonderful international faculty development program. And I can see the number of participants who are really interacting through chat or through voice. The session was really interesting, and I'm very much thankful to the entire team for giving me this opportunity. Thank you very much.
Thank you, ma'am. Thank you so
Thank
much.
you, ma'am.
Anita ma'am, good afternoon ma'am.
Yes, ma'am, please.
I'm Sugandha Kundalambi from Horticulture College, Agri University ma'am, Tamil Nadu Agriculture University.
Yes, ma'am.
Very, very useful to you, to me ma'am. Actually, the research perfect. Mathematics is also very nice ma'am.
Yeah, ma'am. Actually, I am a computer science background with mathematics as my UG degree. But I involve myself with this mathematics because since we are basically a mathematician upgraded to computer science, I can see that there is too many things can be done with the mathematics. Except without mathematics, the whole life is nothing. So, as with the respect to the point of research work, I can see that the algorithm part or any mathematical calculation or implementation, we no need to depend upon any tool. We can create our own way of producing the research results, which is really effective to the near future, which can help us to go for various impact factor journals as well as with the patents.
Yes, ma'am.
So I request our people also not to depend on the tools, much about the tools. Rather than that, you can analyze your data and we can get our results.
Okay, ma'am.
Thank you very much, ma'am.
Thank you, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Bye. Organizers, can I leave the meeting then? Okay. Thank you, people. Bye.
Thank you, Doctor. Wonderful.
Thank you, sir. Thank you, sir. Thank you very much.
Especially the comparison between statistics is offer.
யாரோட வாட்ஸ்அப் இது என்னோட நான் அவர் அனுப்பியிருக்காங்க சார் இப்ப அனுப்பியிருக்கேன் பாருங்க அவங்களுக்கு எப்படிமா வருது? நார்மல் மெசேஜ் ஆப்சன் பிரசன்டேஷன் அந்த மாதிரி போடுங்க சார், போதான்னு பார்க்கலாம். Can't share feedback link. Can't share feedback link. யாராவது ஒரு ப்ராடக்ட்ல இருக்காங்களா? அப்ப நமக்கு மட்டும் டிஸ்பிளே ஆனா அப்புறம் என்ன அர்த்தம்? Organizer, responser, chat feedback. ஹாய் போட்டா வருது, லிங்க் போட்டா வர மாட்டேங்குது.